So here's my Hovercart running off a DeWalt battery. Got a phone that connects to the controller and sends the data to the Arduino via serial. And wheel that swivels, caster on the front, and then of course the Hovercart, or the Hoverboard I should say, in the back, and a nice little chair. So I did also add this self-driving mode. I had a couple different target locations, and that green arrow is what it's trying to target to turn to, and the white is what it's currently at. The red is what north is. It sort of works, but the GPS is not that accurate, so it ends up not working that well. But let's just kind of show you what happens here. And it's hopefully towards the end of the driveway here. It does a little self-correcting as it goes. Again, the GPS is within a couple, 4 or 5 yards, so not super accurate. We might end up in the ditch here, but just okay. So now it should hopefully start going left more, or I can manually switch to the next location. Let's see what it does. So yeah, looks like I'll have to switch to the next location manually. After a few button clicks later, okay, there we go. Now it's kind of heading this way. Let's go over how this works on a bit more technical level. So first of all, the power source is a 20 volt DeWalt battery for like a drill or anything like that. This just happens to be the same voltage that the original battery had. Now, the whole reason I started this project was because the battery on the hoverboard died, and you could power it with the same voltage, but there was some sensor wires for probably temperature that I couldn't get a replacement for, so I didn't know how the wiring worked on it, and basically the hoverboard would not move if it was powered because those wires were not hooked up. And I had a really hard time trying to figure out how to stabilize the hoverboard, so that's why I kind of made into this cart orientation. But there is an Arduino that I put inside of this hoverboard. The main board components are completely taken out. There are 2 DC motor controllers inside here, and those are what drive these motors from like the Arduino's instructions essentially. Now, I did used to have this joystick on there, and that was the original lane before the controller, but it was kind of a pain in the butt. Didn't that work that well, and I want some more control. Plus, the 3-stranded wire worked fine, but then I had this additional wire running along, and now I could have made this better, but if it came apart, the signal would actually get lost, and it would start driving away, so that was kind of a problem. I knew I wanted to make this remote control, but I didn't know how to connect this to the Arduino. I probably could get like a shield for the Arduino to connect to it, but it was not super simple and I didn't have the parts for it. So I'm like, what else could I do? I thought, hey, I can use this old Android phone, write a really simple app that can feed commands through serial to the Arduino, and the Arduino can respond accordingly. So we got rid of that other joystick, made a simple app for this. The app has, as you can kind of see there, 0.1x speed. I can bump that up and down with the D-pad. This just makes it go faster and slower, of course. And then each joystick controls each wheel. So forward, backwards on the left wheel, forward, backwards on the right wheel. And with that in mind, you can do forward and backwards and spin this, which I'll show you right now. I apologize, I need to get an actual tripod, not this tiny little thing. But anyways, so a couple buttons on here to do stuff. Up and down on the D-pad, that's what controls our speed. So this would be all the way up, 0.9, 0.8, 0.7, 0.6, etc. We'll just bump that down. A and B enable and disable the motors. Well, it doesn't really disable them, it just the app decides to send data or not. So if I press B and move this around, it does nothing. If I press A, then it'll start moving. So if we enable these, maybe bump up the speed a little bit. I can kind of show you what I was talking about before. So left joystick, right joystick, you can kind of see it's only moving one at a time. If I go one forward, one backwards, it'll spin it actually because that front caster swivels, which is really nice. So we can do really quick spins and stuff like that, which is really nice. But that's basically how it works, it's just forward, back, forward, back. And it does stop pretty quick, like if you're going forward and then slam on the brakes. Now there's no weight on there, so I'm not on there, but it does stop pretty quick. And of course we bump up the speed. I may run into something, but it goes faster. Apart from that, that's mostly what there is to it. The Arduino code is pretty simple. If you guys want to take a look at that, I guess I could upload that, but it's really not that complicated at all. The phone sends left and right, like left go 0 to 255 or down to negative 255 for reverse. And the Arduino gives power and direction accordingly to each wheel. I did forget to say there is a slight left and right trim adjustment. So basically just spin one wheel faster or slower depending on, because it doesn't drive perfectly straight. If you actually look at my thing here, it's probably hard to tell, but it's not that level. I just bolted in these boards, but it's not that level, so it doesn't drive perfectly straight. So the steering adjustment helps that a little bit. Anyways, if you guys want to look at some of the code or something, just let me know, and I can probably upload that on GitHub for you guys. So thanks for watching, guys, and let me know what you want to see next.